Welcome to solverfy.
Okay. 3-methylpentanoic acid is going to be a carboxylic acid, and it's going to have a 5-carbon chain. So we are going to have, let's find the pen here. There it is. So we're going to have a 5-carbon chain. So 2, 3, 4, 5. Off of that, we're going to have an OH group and a double bonded O. That's our carboxylic acid coming off what we would consider our first carbon there, because that's the carboxylic acid. The third carbon, okay, so remember that first carbon is where the carboxylic acid is found. So our third carbon will have a methyl group because it was 3-methylpentanoic acid. Ethyl methanoate is going to be, ethyl methanoate is going to be an ester, right? So we know that an ester has a double bonded O and a single bonded O. Now this one is methanoate. So that means we just have one carbon with the double bond, and it's ethyl methanoate, which means on the other side of the oxygen, we have a 2-carbon chain. So we have a CH3, CH2, single bonded O to our double bonded carbon O to O and hydrogen, right? So the methyl is the 1-carbon and the ethyl is the 2-carbon chain. Methyl benzenoate is going to be similar. It's going to have a benzene with it, right? So our benzenoate means that the benzene is actually attached to the carbon with the double bonded O. So we're going to have a 6-carbon chain here, or 6-carbon ring with the double bonds there. And remember, that's not an oxygen. Those are double bonds. So just so we don't get it confused, remember you can draw the resonance, you can draw that circle in the middle to represent those double bonds, right? That's single bonded to the oxygen over here, and it's a methyl group, so that's a CH3. So methyl benzenoate. Then we have 3-chloro-2,4-dimethyl hexanoic acid. So hexanoic acid is going to be a 6-carbon carboxylic acid. 3, 4, 5, 6. The first carbon is going to have the carboxylic acid portion attached to it. From there, we have a 2,4-dimethyl. So that means we have a methyl on 2 and a methyl on 4. And we also have a 3-chloro. So we're going to have a Cl there for chloro. And the rest of these will be hydrogens, right? So we have hydrogen. Anywhere that I'm putting a dash here, we'll have a hydrogen attached to it to complete the bonds around the carbon.